Assalamualaikum warahmatullahi wabarakatuh. So today we're going to look at chapter 2, lab. So we're going to look at the question that I've already posted in during class. So we're going to solve it using both Excel and also MATLAB or Octave. So we already solved the problem using Excel during the class session. So today we're going to look at how we can solve it using Octave. So the problem is regarding a spherical tank. So we're going to look at what is the depth of the water in the tank, given that the tank must hold 30 meter cubic of water. So the tank has a radius of 3 meter. So we're going to look at how to solve it first using graphical method. So I'm going to guide you step by step on how to solve it using graphical method in Octave. And later on, you're going to complete your assignment by using one of the methods that is assigned to you. So we're going to look at I'm going to share you the screen because I'm going to go back and forth to Octave. So first, we look at Octave. So whenever we want to work with a program which is longer than few lines, usually we're going to work with the editor. So you're going to open your editor if you haven't opened yet. So this is the button for editor. So you can click on it. So you have an editor screen for you. So you can also go between command window and editor if you need to look at the end result of your program. So first we're going to key in all the required information. So the first information that we have is the radius of the tank. So it is 3 meter. So if you want to key in, if you want to save the unit, so you cannot put it in the program itself, but you can always put it as a command. So you can put it here M. So you know that later on when you want to revisit the program that you have already done, so you know that R, you're talking about the radius, which is in meter. And then the second information that you have is on the volume. So the volume of the tank, it must hold 30 meter cubic of water. So you can also put it here. And then you can straight away go into your function so that you're going to look at. So the function here is if you want to key in the function and you want to make sure that the function is what you call, you can change the variable within the function. So you have to key in terms of this. So this is one way of how to write the function in Octave. You can also use a symbol if you're using MATLAB. And for Octave, I've already checked. If I want to use a symbol, I cannot use they don't have the function for that. So I'm going to use this. So the equation that you're going to look at, you're going to plot is this, the volume. So you have pi. So there's a predefined function for pi. So you can straight away use pi. And then you have h. Square. And 3 minus h, 3. So if you look at the function, if you want to give a value, a single value for the function, you can write it this way. So if I may demonstrate this and through the command window. So let's say if I run it, so I have to save it first. And H, right? So if I run it, so I only put in the radius, the volume, and also the function, the command for function. So if I go back to the command window, so I have this. So this is the function that I'm looking at. So if I want to calculate the value of the function, given that the H is equal to 3, for example, I can write it on the command window, and then it will calculate for you straight away. But in this case, I want to plot a graph for a range of values. So because the value of H varies between 0 to R. So in this case, if you look at the bisection method, I gave you an initial guess of 1 to R, but then the depth of the water can be ranging from 0 until 2R, so 2 of the radius. So you can use that value to plot your graph. So let's say if you go back to editor, so if you set a value of H, which is from 0 until 6, or 2R, 2 radius, and then you want it to be plot within a certain interval. So let's say the interval is 0.5. So by writing it this way, so basically you're telling that the value of H is 0 until 2R with a step size of 0.5. So you're going to have several data for H. So when you do this, so if you again, so if you plot, let's say here, plot H to FH, do this. If you run the program, so you will see that the command for plot is not does not go through. So what happened is that, so it tells you the error. So where's the error for the function? So the error here is for x power of y. So this is only permitted if the argument is scalar. So if you have a value of h, so ranging from 0 until 6, so meaning you have 13 data, so you cannot use this. So what you can do is that you can do array power. So can add what do you call titik here, and also here, so that this acknowledges that you have to do the power function for all the h, for 13h. So if you have a single h, there's no problem, but then now you have a matrix of 1 by 13, so you want to make sure that all the h within your matrix is powered by 2. So you put in the dot there, so dot power h 2. So this way it's going to calculate the power for h for each element within the class, within the variable. And then when you have 13 values here, so when you want to do multiplication over here, it also triggers the problem with which h are you talking about. So that's why we have to also include a dot here before the multiply. multiplication. So now if we run it again, so you will get this. You will get a plot of this function. So the question asks, so what's the value, what is the value of H if you have a volume of 30 meter cubic? So if you look at the graph here, you have to look at the value of 30, and then from there, so that's the value of H, the depth of the water. So if we want to do here 30, which is somewhere here, if you look at the value at the bottom left of the figure, so for 30 for a volume of 30, so you need a depth of 2 meters. So this is what we get for graphical. But then if you want to do a root finding, if you want to use a root finding method, it has to cross the x-axis. So the value here must cross the x-axis. What you can do is that you can subtract the value of the volume so that the whole graph will be shifted down. So I'm going to show you the difference between both plots. So H, and then this is H. So I'm going to plot two graphs on the same figure. Okay. Plot it. I will get two graphs. So one will cross the x-axis, and the other one, this is the original plot, and this one is already subtracted by 30. So you will see that in here, the value of 30 already crosses the x-axis. So if you want to look even closer, so you can turn on the grid. So if you're using MATLAB, you can use the function grid on to turn on the grid. So here it's already embedded in the figure. So if you look at the grid, so you will see that the value of 0 is around 2. So, and also you get the value from the original function, 30 is also around 2. So that's how you solve the problem using graphical method. So if you want to do if you want to do the graphical method for your own problem, so what you need to do is that you need to lay down all the variables that you have, and then write the function. And then by plotting the function, you can see that where it crosses the x-axis. So from there, you can work out your solution for all the remaining method. So you're going to be working with only one method per person. So you're going to use, for example, if you use bisection method, so you're going to use that information, the information that you gathered from the graphical method for the initial guesses. So in this case, for example, so we know that the root is around 2. So we can use the initial guess of 1 to 3 as our initial guess. So we know that the 2 value already bracketed the root. So if you're using bisection, for example, and also false position. And then when you're using open method, the rule is to use a value which is close enough to the root. So if you use 1, for example, it is good enough. or you can use a value which is after the verb. So 3. So it depends on your problem and how you argue about gathering the initial guesses. So hopefully you can try to do your to do the graphical method for your problem, and then in 1 hour we're going to meet and we're going to look at how further along are you with solving your assignment 1. Okay, I think that's it. Thank you very much.